Continuing with the same chapter, that is your air compressor. Previously we were discussed about the work input to the compressor when we are not considering clearance, that is without clearance. Then now we will consider the clearance in the cylinder, then see what will be the work input. So what is clearance? Before we going to discuss about that, you know that what is clearance. What is clearance? The clearance volume is that the space left in the cylinder when piston at TDC position. When the piston is at TDC position, the top, the head of the piston and the cylinder head, the gap or space left between that is known as your what? Is known as your, that is your clearance volume, or basically before in the IC engine case it will be called as what? It will be called as combustion chamber also. It is provided. Why it is provided? It is provided to avoid the piston striking the cylinder head. If no clearance is given, then the piston will directly strike with the cylinder head. So to avoid that, the clearance volume is given. Also in the clearance volume, the valve actuation will be accommodated. So no, the suction and delivery valve also located in the clearance volume. So in the clearance volume, with first term we will discuss, that is your clearance ratio or percentage of clearance. What is clearance ratio? The clearance ratio is the ratio of clearance volume to swept volume, VC by VS, that is known as what? Clearance ratio. See, when you are considering clearance, what will happen? So, if we consider the clearance in the, if we consider the clearance, suppose this is your IC engine, this is your engine, okay? So, this one is your cylinder head, this one is your TDC top dead center, and this one is your BDC, that is your bottom dead center, TDC and BDC. So, this is the piston. So, here the one directional valve, that is your suction valve, and this one is your what? This one is your delivery valve. So, this volume, when piston is at TDC position, okay, the space left between the cylinder head and the piston, this volume is known as your volume, this is known as your clearance volume. Then when the piston move from TDC to BDC, this volume is known as your which volume? That is known as your VS, that is your swept volume. It is known as your swept volume. So, what will happen? So, imagine, when you are not considering any clearance, what will happen? 2 to B after delivery, B to A, there is no air left inside the cylinder. So, that is a straight line. But in this case, what will happen? During the suction, when the piston move from TDC to BDC, during the suction stroke, the negative pressure will be created here. So, if you draw the PV diagram here. See, this one is your TDC top dead center. Okay. This one is your BDC, that is your bottom dead center. Now we are considering what? We are considering the clearance. So this is the clearance. VC, clearance volume. So when the piston move from TDC to BDC, that is your suction. That is your suction. This one, when piston move from TDC to BDC, that is your suction. So though we are considering the clearance volume, so here we will start from here. Is that clear? So when the piston move from TDC to BDC, so what will happen? That will be the suction. See, if we are considering the clearance volume, so when the piston move from TDC to BDC, that is your suction. When it will be moved from BDC to TDC, the air will be compressed, and some of the air, and after compression, some of the air will be delivered. Not all the air will be delivered. Some of the air, compressed air, may left inside the what? Some of the compressed air may left inside the cylinder, inside the clearance volume, or the space left in the cylinder, that is your clearance volume. So when the next stroke, when the piston will be moved from TDC to BDC, when the suppose this is the piston, when the piston move from TDC to BDC, then what will happen? This gas is also extended. This gas has some pressure, that is with a high pressure. Was it yes or no? So when piston move from TDC to BDC, at that time the suction will not happen. Why? Because some of the pressure or some of the air is compressed air is left, which has more pressure than that of atmospheric pressure. So what will happen? We have to move the piston from TDC to BDC during the suction stroke, as well as what will happen? This air, this left air is also expand. When it will be expand, its pressure will be decreases. When its pressure will be decreases below atmosphere, when this atmospheric pressure, this pressure, inside pressure will be less than what? Atmospheric pressure. At that time what will happen? The suction valve will open, because we know that agar यहाँ if atmospheric pressure will be more, then the inside pressure should be less, then only suction will be created and the air will be automatically drawn into the cylinder. Though in the space some of the air is there, so air has some pressure. So when piston move from TDC to BDC, at that exact time the piston the suction valve will not open. Why? Because no pressure difference is there. If no pressure difference is there, then this valve will not open. What will happen? When piston move from TDC to BDC, at some point, at this point, suppose, at this point the suction valve is open. Why? Because inside the pressure inside the cylinder will be dropped than that of your atmospheric pressure. So here that is your suction start from 4 to 1. At what time it will be? Suction will be from 4 to 1. So no, 4 to 1 is your suction. Then what will happen? So when at the time of suction, so suction will be end when the piston reaches TDC BDC position. So no, then piston move from BDC to TDC. When the piston move from BDC to TDC, what will happen? The suction valve will be closed and the volume will gradually decreases, and the volume will be gradually decreased. That is your compression. 1 to 2 is your compression. So no, 1 to 2 is your compression. Okay. When the piston reach at some point, when the piston move from BDC to TDC and reach at some point where the pressure will be more increases than that of your what? Delivery pressure. That of a delivery pressure, then this delivery valve will be open. Inside pressure will be increases. When the piston is not reach at TDC. Now see, when piston move from BDC to TDC, the piston is not reach at TDC. Before it will be reach at TDC, some point the pressure inside the cylinder will be increases. If the pressure inside the cylinder will be increases and the delivery pressure will be what? Less. Due to this pressure difference, this delivery valve will be open and air will be delivered. At which point? At this point, air will be start delivering. So air will be delivered up to what? Up to TDC, up to top dead center. When the piston reaches TDC center, the stroke will be completed. So 1 to 2, that is your compression and delivery will be happening in which stroke? From when piston move from BDC to TDC. Yes or no? So when piston reach at exactly TDC, all the air is not delivered. Some of the air is left inside it. So when again for suction, when piston move from TDC to BDC, what will happen? The left air inside the clearance volume will be expand. It will be 1 to 2, 2 to 3, 3 to 4 and 4 to 1. So what to 1 what? Suction. 1 to 2 what? Compression. 2 to 3 delivery. 3 to 4 expansion. Clear? So when the piston move from TDC to BDC, this is your which volume? Swept volume. So with this swept volume, the air must be sucked. With this volume, the air must be sucked. But what will happen? The air will be not sucked at when piston move from TDC to BDC. Air suction will be start from where? From 4 to 1. So this 4 to 1 is known as your what? Effective swept. It is known as your what? Effective swept. It is known as your what? Effective swept. So here to here volume is your what? V1. Here to here volume is your what? V4. So effective swept is your what? V1 minus V4. Effective swept is your what? V1 minus. Is that clear? So next we will discuss. So that diagram will discuss there when you are considering the clearance volume. This is the concept when you are considering the clearance. This is the concept when you are considering the clearance volume. See 4 to 1. Here this one is your what? This position is your top dead center TDC. This is your what? BDC, bottom dead center. When the piston is at TDC, and cylinder head, that volume is known as your which volume? This volume is known as your clearance volume. Piston move from TDC to PDC, that is your what known as soft volume. Okay, this is your total volume. Total volume is your V1. V1 is equal to Vc plus Vs. So no, this volume here to your volume is your what? Here to your volume is your V4. V4. So where the suction will happen? Suction will happen from 4 to 1. Occur in 4 to 1. So total volume is your V1 minus this V4. So V1 minus V4 is known as your what? Effective thrust. At this volume, the air is entered into the cylinder. Clear? Then 1 to 2 is your polytropic compression. 2 to 3, that is your delivery. 3 to 4, that is your expansion. Clear? So this is your volume is your what? V3. So we can say that V3 is equal to Vc. Because this volume is your V3, here to your volume is your V3, and here to volume is your what? It is also Vc, so you can say V3 is equal to Vc. Clear? Okay, then we have to what we have to do? We have to find out what is the work input when you are considering clearance. What is the work input when you are considering clearance? That we have to find out. Okay? So in the next video we will discuss what is the work input.